force and laws of motion. Students, in this section we are going to cover Newton's second law of motion. According to this law, the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. To understand it, let us understand about the term momentum, considering some examples. Students, in this example, you can see that this person is firing a bullet on another person. A bullet when fired from a gun can kill a person. However, if a bullet is just thrown on another person, would not produce any harm. Similarly, if a truck is at rest, it would not cause any harm to anyone. However, a truck with the speed as low as 5 meters per second can kill a person standing in its path. What do we conclude from it? It implies that the impact produced by the objects depend on their mass and velocity. So, the two parameters on which the impact produced by the objects depend is their mass and velocity. We know for a light body to attain high velocity, however, it is very hard for a heavy weight to attain high velocity because it requires large force. Let us study about the term which relates mass and velocity. The quantity that gives relation between mass and velocity is called momentum. Momentum is denoted by small p. So mathematically, we can write P is equals to m into V, where P is momentum, P is equals to mass, that is m, into velocity, that is V. Therefore, P is equals to m into V. Momentum is a vector quantity. Why momentum is a vector quantity? Because momentum is given by mass into velocity, where velocity is a vector quantity. Therefore, momentum is also a vector quantity. It has both direction and magnitude. Students, we have discussed that on the application of unbalanced force on any body, it can produce change in its velocity. Suppose this is a ball which is moving in this direction, and if you apply some force over it, suppose if you kick this ball, then it will start moving at a faster rate. Or if you apply a force opposite in the direction of its motion, then you can slow down its speed. Since the application of unbalanced force changes the velocity, it also changes the momentum, because if there is any change in the velocity of an object, it will directly affect momentum. Therefore, the momentum of the object will also change. The SI unit of momentum is kilogram meter per second. How it is kilogram meter per second? Let us see. We know that momentum is given by mass into velocity, where SI unit of mass is kilogram and SI unit of velocity is meter per second. In previous sections, we have covered the SI unit of velocity is meter per second. Let us go through it once again. Velocity is given by displacement d upon time taken t, where SI unit of displacement is meter and SI unit of time is seconds. Therefore, the SI unit of velocity comes out to be meter per second. Hence, from this we get SI unit of momentum is equals to kilogram meter per second. Hence, the quantity that gives relation between mass and velocity is called momentum. Students, we have discussed that whenever an unbalanced force is applied on an object, then it produces some change in its velocity. This change in velocity will also cause some change in its momentum, because momentum P is given by m into v, where m is its mass and v is the velocity of that object. Since the applied force causes change in the velocity of the object, it will directly change the momentum also. Similarly, force required to change the momentum of an object depends on time rate at which the momentum is changed. So apart from force, the change in momentum of the object also depends on the time rate. To understand this, let us consider an example. In this example, this is a car with dead battery, and this person is trying to push this car in order to give it some acceleration. Students, if this person suddenly pushes this car, that is, he suddenly applies some force on this car and tries to move it, will it move? No, this car will not move on sudden application of force. However, if this person applies some force continuously and push this car over some time, it will result in the movement of the car. Let us see. See, this person is gradually applying some force, and therefore this car has picked some velocity with gradual increase in its acceleration. Hence, we can say when this person has applied gradual force on this car has gained some acceleration. However, if this person applies a sudden force on this car, that force will not produce any change in the acceleration of this car. Thus, we can conclude that the change of momentum of the car is not only determined by the magnitude of the force, but also by the time during which the force is exerted. Therefore, we can conclude force required to change the momentum of an object depends on time rate at which the momentum is changed. With this, we can conclude that force required to change the momentum of an object depends on time rate at which the momentum is changed. Students, we have learned what is Newton's second law of motion. It states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. Now, we will understand mathematical formulation of second law of motion. For mathematical formulation of second law of motion, we will consider an object of mass m which is moving along a straight line with initial velocity u. So what is the initial velocity? Initial velocity is the velocity of this object with which it has started moving from rest. This object is uniformly accelerated over time t to reach velocity v, and it is applied by a constant force F during this time period t. So for this object, the initial momentum is given by P1, which is equals to m into u, where m is the mass of this object and u is the initial velocity. The final momentum of this object is denoted by P2, which is equals to mass into final velocity, that is v. Change in momentum will be equal to P2 minus P1, that is initial momentum minus final momentum, P2 minus P1. Putting down the values of P2 and P1 from here, it comes out to be mv minus mu. If we take m common, then it comes out to be m into v minus u. The rate of change of momentum is proportional to m into v minus u upon t. So here we are finding out rate of change of momentum. So we have divided it by time t. Or if we talk about the applied force, then F is proportional to m into v minus u upon t. Why we have replaced rate of change of momentum to force applied? Because according to second law of motion, it states that rate of change of momentum of an object is proportional to the applied unbalanced force. So rate of change of momentum is this one, which is proportional to force applied. So if we remove this proportional sign by a constant, then we will get F is equals to K into m into v minus u upon t. So if you remember, this portion v minus u upon t is acceleration. It is the formula for acceleration. So we will replace v minus u upon t with a, that is acceleration. Here force comes out to be F is equals to K into M into A, where A is equals to V minus U upon T and K is equals to constant of proportionality. So we have obtained F is equals to K into M into A. The SI unit of mass is kilograms and SI unit of acceleration is meter per second square. Because acceleration is given by velocity upon time and SI unit of velocity is meter per second and SI unit of time is seconds, therefore it comes out to be meter per second square. The unit of force is so chosen that the value of K becomes 1. Therefore, 1 unit of force is defined as the amount that produces an acceleration of 1 meter per second in an object of mass 1 kg. From here, the value of K becomes 1. Therefore, we get F is equals to ma, that is force is equals to mass into acceleration. The SI unit of force is Newton. Based on the name of a great scientist who have discovered these laws, SI unit is given by his name Newton and it is also given as kilogram meter per second square because the SI unit of mass is kg and the SI unit of acceleration is meter per second square. Hence, SI unit of force is equals to kilogram meter per second square or Newton, which is denoted by N. Thus, from here, we have mathematically obtained second law of motion, which states that rate of change of momentum is directly proportional to the unbalanced force applied in the direction of force. Here, rate of change of momentum is ma. As we have seen, the value of A is V minus U upon T. Therefore, this rate of change of momentum is directly proportional to this force. Therefore, the second law of motion is obtained mathematically. We can apply second law of motion in the case where a player catches a fast moving cricket ball. The fielder gradually pulls his hands backward while catching the ball. Let's see how. See, this player when catches the ball pulls his hands backward. In doing so, this fielder increases the time in which the velocity of ball decreases to 0 in his hands. So this ball is coming from here, it has certain high velocity. By pulling his hands backward, he is earning this extra time in which the velocity of this ball will become 0. If the fielder does not pull his hands backward, then the ball will suddenly stop. That is, the velocity changes to 0 in very short interval of time. And this will hurt the player with high momentum. At this point of time, since the velocity is very high, the momentum with which this ball is coming down is very high. So if this ball suddenly stops in his hands, the high momentum will hurt this player. Therefore, by gaining this extra time, he is reducing the momentum in order to prevent himself to get hurt.